Comes to section 10.2, area between two curves. This time we're asked to find the area between two curves, y equals sine x, y equals cos x. We do need to have some ability to draw those two, I think, to do this question properly. So a sine graph looks like that, and a cosine graph, to do it somewhat accurately, is going to look like this. Now pi over 2 is right here, so the area between these two curves, actually between 0 and pi over 2, consists of this little region there and this little region here. And it's important to understand that that's two separate little regions, because for the first part of it, one curve is higher than the other. The y equals cos x curve is above the sine curve, and then for the second part of that region, the y equals sine x curve is higher. One thing we need to know then, if this is 0 and this is pi over 2, is where do they actually intersect. Now if you know your unit circle well enough, you know when sine and cos intersect there for the first time. Another way to solve that would be say, where does tan equal 1? But any way you look at it, the first answer you get there is 45 degrees, or in other words, pi over 4 radians. So what we do is we do this problem in again in two pieces. We say, well, we need to find the area from 0 to pi over 4 when cos x is higher, so cos x minus sine x dx, and then we're going to add that to the area from pi over 4 to pi over 2 of sine x minus cos x dx, because that function goes on top. If you don't do that, if you try doing it all together, you might be surprised at your answer. Sometimes you get an answer where the area is 0, areas are negative, all kinds of weird things if you don't recognize that one function moves above the other for part of it. So take the antiderivatives here. We get, in this case, sine x plus cos x that we're going to evaluate from 0 to pi over 4. And then we get actually lots of negative signs in this one, negative cos x minus sine x, and we're going to evaluate that from pi over 4 to pi over 2. So when you look at it closer, you get sine of pi over 4 plus cos of pi over 4 minus sine of 0 plus cos of 0. Now you should have some brackets around that one. That's the first piece of the area. And the second piece of the area is going to be negative cos of pi over 2 minus sine of pi over 2, and then that minus negative cos of 0 minus sine of 0. So once people get the hang of the antiderivative or integral piece of this, the keeping track of brackets and negative signs becomes probably the hardest part of this question. What you end up here is root 2 over 2 plus root 2 over 2 minus 0 plus 1, so minus 1. And then in the second bracket here, you end up with 0 minus 1, so 0 minus 1 minus, and then I've got, and sorry, this should be pi over 4, not pi over, or sorry, not 0. We've got negative root 2 over 2 minus root 2 over 2. First bracket, then, if I add these two together, I just get root 2, so then I've got root 2 minus 1. And it turns out that if you do this carefully, you see that the second bracket gives you the exact same numbers. And you end up with root 2 minus 1 plus root 2 minus 1, so 2 root 2 minus 2 is the area. The fact that those two were the same just speaks to the fact that these two little slivers of area were symmetrical, same size. And so we've got, 2 root 2 minus 2 square units as the area between those two curves from 0 to pi over 2.